Welcome you all once again for this revision classes. In this revision classes, we're going to discuss some problems, some theoretical questions, which includes taken from your question bank only. So subject is elements of machine design and theory of machine. Okay, for some students. In this video, 6th unit, that is CAMS, we're going to discuss. Okay, so let us start with first question. Explain CAM and follower. Okay, so it is 5 marks question. It may ask for your forthcoming exams. Definition. Okay, a CAM is a rotating machine element which gives reciprocating or oscillating motion to another element, that is known as follower. The CAM and the follower have a line contact and constitute a higher pair. The CAMs are usually rotated at uniform speed by a shaft, but the follower motion is predetermined and will be according to the shape of the CAM. The CAM and the follower is one of the simplest as well as one of the most important mechanism. Okay, so these two parts are very much important, which functioning useful work. Okay, simplest as well as one of the most important mechanism in the modern machinery whatever we are using today. The CAMs are widely used for operating the inlet and exhaust valves. So this kind of CAMs we are using in for high speed engines as well as to operate the inlet and exhaust valves, whether it may be in boilers or else in internal combustion engines also we can use, and also in automatic attachments of the some machineries, paper cutting machines, spinning and weaving textiles machineries, feed mechanism of automatic lathes. Okay, so this is all about explanation regarding CAMs and follower. Okay, so this may ask for your exams for 5 marks. Next, moving on to the next question. Explain the types of follower. So it is broadly classified into 3 types. We will see one by one according to the surface in contact. Okay, the follower may divide into further 3-4 types, means that the first one is knife edged follower. So here this one is knife edged follower. So end of the follower is knife in terms of knife, so that's why it is called as knife edged follower. Then knife edged follower means when the contact end of the follower has a sharp knife edge. Just only I told. Okay, this is only given in the explanation. Then second, flat faced mushroom follower. So see here, flat faced mushroom follower. This one is flat faced. So end of the follower is in terms of flat. So that's why it is called as flat faced mushroom follower. Then spherical faced follower. So see here. So spherical is shown in this picture. End of the follower is fixed with roller or else this spherical. Okay, so here it is clearly shown, spherical faced follower. So that's why it is called as spherical faced follower. Then second type, according to the motion of the follower. The follower according to the motion are of the following 2 types. So it is further divided into 2 types. First one is reciprocating or translating follower. So reciprocating means when the follower reciprocates, guides, the CAM rotates uniformly, and it is known as reciprocating or translating follower. So it is shown in the figure A and D. So see here, this one is considered reciprocating type follower. Then second, oscillating or rotating follower. So it is predetermined oscillatory motion of the follower, so it is called as oscillatory follower. The follower is shown in figure E. See here. So this type of follower is used to get a oscillating rotating follower. Then third type, according to the path of the motion of the follower. So according to path of the motion of the follower, so it is further divided into two types, radial follower and offset follower. Just see here, radial follower and offset follower. So this one is offset and radial follower is here. Okay, central axis for the cam as well as that follower is same, then it is called as radial. If the some amount of distance is given for central axis of the follower as well as cam, some amount of distance is given for the fixing of the cam, then that distance is called as offset. So this is offset and radial type follower. So these are the some classification of the follower. So this may ask for 10 marks. Okay, then next question. Explain the types of cams. So whatever we just saw the types of the follower, similar type of in the cams also we are having. So first type is radial or disc cam. So it is shown in the figure A. So this one is radial or disc cam. In radial cam, the follower reciprocates. So here what happens? Follower reciprocates will be taking place, or oscillation will be taking place in the direction perpendicular to the axis of that cam. So this is all about radial or disc cam. So it is clearly shown in the figure A. Then second type, cylindrical cam. In cylindrical cam, the follower reciprocates. So here what happens? The follower starts reciprocates or oscillates in the direction parallel to the cam axis. So it is parallel to the cam axis. So that is regarding cylindrical cam. The follower rides in a groove. Okay, so here shown some groove is shown. So on that groove only that follower starts riding. Okay, so it is clearly shown in the figure B. So this is all about types of the cams, radial or disc cam, and second one is cylindrical cam. So this may ask for your exams for 5 to 10 marks. Okay. Then next, draw the displacement diagram for uniform velocity and SHM motion of the follower. So here SHM is nothing but simple harmonic motion method. In the classroom only I told regarding this one. So this one asks for 10 marks definitely. Okay, important for exam point of view, means that how to draw the displacement diagram, that I told in the classroom clearly. Okay, so this one is displacement diagram and projection of these lines, that is to be drawn velocity diagram. Okay, so you just go through the notes, you come to know. Okay, so in every cam problem, solving the cam problem, you need to draw this displacement diagram. So this displacement diagram includes 360 degree. Okay, that I told clearly in the classrooms, and this height is stroke length. Okay, that I told, and theta O is outward stroke and theta R is return stroke, and S is stroke length. Okay, the remaining is dwell. you know very well. Okay, and this portion is velocity diagram. Okay, in the exam, in the problem itself, they are going to ask draw the velocity diagram, includes displacement diagram also. Okay, so this definitely they will going to ask for 10 marks. Only procedure you have to draw. Whatever you are drawing the displacement diagram as well as velocity diagram, after drawing those you just write the procedure that is given in this notes only. Okay, then moving on to the next question. Draw the displacement and velocity diagram for uniform acceleration and retardation motion of the follower. So this one is displacement and velocity diagram for uniform acceleration and retardation motion method. Okay, so this is also asked for previous question papers. You just go through the previous question papers, you come to know many time asked this question. So that's why this one is also important. First you have to draw the displacement diagram, then velocity diagram. The projection of the lines from that displacement diagram will gives the velocity diagram. Okay, and this below diagram shows the acceleration diagram. Okay, which is projection of this velocity diagram. Okay, projection of the displacement diagram will gives the velocity diagram, and extension of that velocity diagram will gives the acceleration diagrams. And after drawing those all things, you just write the procedure. Okay, so this helps to get 10 marks. So next, moving on to the next question. Okay, these two questions are very much important for forthcoming exams, because if he may ask the problems as well as theory part. In that theory part, definitely he will going to ask some questions like definition or classification, or else directly drawing the displacement diagram with the help of that uniform velocity with simple harmonic motion method and uniform acceleration and retardation motion method. Okay, like that he will going to ask. That's why I am telling. Okay, this is very much important for exam point of view. Then moving on to the next questions. Explain various terms used in radial cam. Okay, whatever we are using some terms in the while drawing the radial cam. Okay, those are like base circle, trace point, pressure angle, pitch point, pitch circle, pitch curve, prime circle, that I told in the classrooms very clearly. Okay, let once again we will going to see that definitions. First one is base circle. What is base circle? It is the smallest circle that can be drawn to the cam profile. While drawing the cam profile, whatever we are drawing the smallest circle, that is called as base circle. Okay, next, trace point. So this one is base circle. Then next, trace point. Trace point is nothing but it is a reference point on the follower and is used to generate the pitch curve. So it is the trace point. Next, pressure angle. It is the angle between the direction of the follower motion and normal to the pitch curve. This angle is very important in designing a cam profile. So if the pressure angle is too large, reciprocating follower will jam in its bearings. Okay, so this is all about this pressure angle. Then pitch point. It is a point on pitch curve having the maximum pressure angle. Then pitch circle. It is the circle drawn from the center of the cam through the pitch joint, that is pitch circle. Then pitch curve. It is the curve generated by the trace point as the follower moves relative to the cam. So it is used in knife edged follower. So pitch curve is important. Then next, prime circle. So this one is very much important because so many times asked this one. Definition. It is the smallest circle that can be drawn from the center of the cam to the tangent to the pitch curve. This is prime circle, and this can be drawn during knife-edged follower and flat-faced follower. Okay, so this is all about prime circle. The next definition, lift or stroke length. Okay, so here lift is, it is the maximum travel of the follower from the lowest position to the topmost position. Okay, in displacement diagram, from smallest position to the largest topmost position, that distance is called as lift or stroke. Okay, so these are the definitions which may ask in the exams directly. They may ask like define or else explain base circle and prime circle, like that. Okay, or else directly they can ask like explain various terms used in radial cam. Okay, so you have to prepare for this one. Then next question, draw the displacement and velocity diagram for uniform velocity motion of the follower. So whatever we discussed from the previous questions, okay, you just follow those procedure. Means that you have to draw the displacement diagram and velocity diagram and acceleration diagram. This only comes when by practicing. Okay, you have to practice it, then only it will comes to draw this displacement and velocity diagram. Method is uniform velocity motion of the follower. Okay, and this one is 10 marks question. Definitely they may ask for 10 marks. So in this question, just they told to draw the displacement and velocity diagram. Okay, not asked explanation. Okay, if they ask the explanation regarding this displacement and velocity diagram of the uniform velocity motion of the follower, then draw this displacement, velocity and acceleration diagram and write the procedure. Okay, how you drawn this displacement and extension of that displacement diagram will gives the velocity diagram, and that velocity diagram extension lines will gives the acceleration diagrams. Like that you are going to explain in your own words, no problem. Okay, then moving on to the next question. So we will discuss some problems of the CAMS. Okay, so here a CAM is to give the following motion to a knife-edged follower. Some conditions they given. First one, outward during 60 degree of the cam rotation. Then second, dwell for the next 30 degree of the rotation. Then third, return stroke during next 60 degree of the cam rotation. And fourth, dwell for the remaining 210 degree of the cam rotation. The stroke of the follower is 40 mm and the minimum radius of the cam is 50 mm. The follower moves with uniform velocity during the outward stroke and return strokes. Draw the profile of the cam. And he supposed to ask, the axis of the follower passes through the axis of the camshaft and axis of the follower is offset. Okay, two types of question they asked. Means that central axis is same, and after that radial means that offset asked. Offset is 20 mm of the axis of the camshaft is given. Okay, first you have to draw the displacement diagram with the help of these given datas. First write down the given datas. After that, with the help of that datas, you have to draw the this displacement diagram. Okay, means that which covers completely 360 degree. Okay, you have to first take the scale. Don't forget to take the scale. With the help of that scale only, you need to draw the displacement diagram. After taking that scale, you have to write on your page. Okay, don't forget to write. Then next, drawing the cam profile. With the help of that displacement diagram only, you have to draw this cam profile. So here this one is base circle, So according to your given data only, you have to draw the base circle, and follower, that will gives the that how much is the stroke length is given, that only you have to draw vertically. Then degrees you have to mark on this base circle, then divided into 6 equal parts. Okay, then extension of those lines and draw this smooth curve, that is the cam profile. Okay, I told in the class itself very clearly. Okay, don't forget, make a dark line that will shows that cam profile clearly. So this is all about profile of the cam when the axis follower passes through the axis of the cam shaft. So here follower central axis is passes through the center axis of the cam shaft. Okay, so this is the given condition we solved. Then second bit, profile of the cam when the axis of the follower is offset 20 mm is given, means that from the base circle follower axis should be apart from 20 mm, that is called as offset. Okay, don't forget and don't get confused, this one is important. 20 mm offset is given. So after that remaining procedure is same, by putting some degrees, okay, and divided by 6 equal parts, like that, similar to the previous one. Then draw this cam profile. Okay, so this is all about drawing the cam profile. So this type of problem he may ask for 10 marks. Definitely one problem will comes, whether it may be central axis is same, whether or else offset may ask. This is the one type of problems. Okay, then second we are going to see another problem. A cam with minimum radius of 25 mm rotating clockwise. Okay, first you have to read the problem carefully. Okay, then write the given data. So here a cam with minimum radius of 25 mm is given, rotating clockwise at uniform speed is to be designed to give a roller follower. So here type of the follower is roller follower is asked to draw. At the end of the valve rod, motion described here below, means that some conditions given to raise the valve through 50 mm during 120 degree rotation of the cam. Second, to keep the valve fully raised through next 30 degree. Then third, lower the valve during next 60 degree. And fourth, to keep the valve closed during the rest of the revolution, that is 150 degree. The diameter of the roller is 20 mm and the diameter of the cam shaft is 25 mm. Draw the profile of the cam when line of the stroke of the valve rod passes through the axis of the cam shaft, and B, line of the stroke of the offset 15 mm from the axis of the cam shaft. The displacement of the valve while being raised and lowered is to take a place with simple harmonic motion method. Determine the maximum acceleration of the valve rod when the cam shaft rotates at 100 rpm. Draw the displacement and velocity diagram, acceleration diagrams for one complete revolution of the cam. So this is the given problem. Okay, first read the problem carefully, means that what the given data is given, theta how much, theta r how much, okay, and what is the stroke length, like that you need to first understand clearly, then write the given datas. Okay, yes how much, theta how much, theta r how much. Okay, then if he may ask revolutions given, then you have to write all the details carefully. Okay, then next procedure, draw the displacement diagram with the help of that given data. So type of the method, which one is given, first you have to analyze, according to that one only you have to draw the displacement diagram. Okay, so your type is given SHM, with the help of that simple harmonic motion method only you need to draw the displacement diagram. Okay, theta O and this, and with the help of this, and divided by 6 equal parts. I think you all know about this one. Okay, then next procedure, drawing the cam profile. So one thing you have to concentrate here, type of the follower is given roller follower. Okay, so in the previous problem we solved with knife edged follower, and in this problem type of the follower is roller follower. So similar to that previous problem, only thing is that roller is we can use here. Okay, then after that, marking that degrees on this base circle and divided by 6 equal parts during outward stroke and return stroke, and remaining period is 12. Okay, and prime circle you need to draw, and camshaft that base circle you need to draw, and mark the 6 equal parts. Okay, after that marking you have to draw that extensions of the lines from this point, because central axis is same, that is a bit we are solving here. Okay, so after that you just draw the rollers on every lines divided by 6 equal parts. Okay, so after that we are having the smooth curve like this. So that itself is called as this cam profile. Then B bit, if suppose in this he is not asked for drawing that offset. If he asked for drawing the offset, then at that time you just draw the offset circle from this central axis of the follower apart from this distance. Means that whatever he offset asked, that much distance you have to maintain. Then draw the cam profile. So this type of similar problems only in the exam comes. Okay, you have to practice, then only it will comes. First you have to understand the problem clearly, what are the given data is given. Okay, then write it clearly, with the help of that draw the displacement diagram, then with the help of that displacement diagram draw the cam profile. Similar type of problems will comes, and in the exam, in the classes only I told a number of problems. You just go through those problems, refer those problems. So here some questions we discussed, means that theory questions also we discussed, which will going to help for your studies. So this is all about the CAM 6th unit. Okay, so this may comes for 20 or 25 marks in the exams. So practice the problems as well as theory questions. Okay, practice the diagrams regularly, then it will helps to get a good marks. Thank you.